Thank you so much for joining and welcome to our new webinar. Hope everything is good with my audio and everybody can listen me properly. So the name and the topic of the new webinar is unlocking the power of LoRaWAN for IoT applications. We will speak about our protocol, the LoRaWAN protocol, and then we will also bring some real-life case. I will be presenting the webinar. I'm Ilenia Carola, and I'm the Business Development Manager here at MAMWLE-xx. And here we have our host, Manuela Schlereth. At least I said it a bit right, from LORIOT. She is the technical account manager. So what does MAMWLE-xx? MAMWLE-xx design embedded systems for power constraint IoT applications. My company design radio modules that help develop data-driven approach to improve operation and efficiency in an industry in general. We based our radio module on a STM32 WiFi by STM Microelectronics that use, of course, the LoRaWAN technology to connect device to the cloud and allow a real-time communication of information, improving the operational efficiency and productivity in a variety of different environments. This is our radio module. Like I was saying, hope that you can see my screen. Can you see it? Okay, perfect. Like I was saying, we are based on an STM32 WiFi. We are perfectly tuned to work on all the band that goes from 8068 to 1950 megahertz. This means that we can perfectly work with the same module, just one module, in Europe, US, Australia, and so on. One of our big plus is the high number of GPIOs. In fact, we have 36 effective GPIOs. This means that our module is really have a high versatility. Then also a big plus is the small footprint of our design that allow a big integration in designs. In fact, it is just 15 millimeters for 16. So just briefly, how the LoRa stack works. So the LoRaWAN devices use a star network topology, which means that they communicate directly with a gateway or a base station, and the gateway acts as a bridge between the device and the LoRaWAN network server. Such as LORIOT, allowing data to be transmitted from the devices to the cloud for analysis and processing. But the question that we would like to answer today is why LoRaWAN? Why we choose LoRaWAN and why we are betting on it. I will now let the floor to Manuela, so she can answer to the question, and she will explain a bit of the main features and advantages of using LoRaWAN, and then we will speak about the different use case. Thank you, Manuela.
Thank you, Ilenia, and thank you for the quick introduction and also having me here today at the webinar. I will quickly share my screen. Yes. So I think it should be now visible to you.
Yes.
Perfect. Thank you. Yeah, so I'm excited to answer the question why LoRaWAN. So to really quickly guide you through the main features of LoRaWAN and also showing the benefits, comparing it also with other technologies. But before we go into more details, so first of all, I'm Manuela Schlereth, and I'm, as already Ilenia said, I'm working as a technical account manager at LORIOT. So before we go into more details about LoRaWAN and LoRa, I would like to start about some facts and figures about LORIOT, and then later going over to showing the LoRaWAN network architecture, which has already Ilenia showed quickly. Then also go quickly through what is actually the difference between LoRaWAN and LoRa, and by also highlighting the main features and the advantages it brings, and finishing also by comparing it to other technology to get a better picture of it and to see the advantage of using it. So about LORIOT, so LORIOT was founded in 2015, and since then we are operating in the IoT sector and especially focused on LPWAN, so which is basically means low power wide area networks, and they're focusing on LoRaWAN. And we have three main offices, as you can see here on the map. So our headquarters is in Zurich in Switzerland. Then we also have our office in Valencia in Spain and also in Budapest in Hungary. And we in this LoRaWAN ecosystem, we are focusing on the software side. So it's basically we are offering a network server. And you can say the network server is basically the brain of the LoRaWAN network. But I will also show you later in the LoRaWAN network architecture where we position ourselves. And basically what we are doing is we are offering our network server in three different ways. So, and you can see we have a globe presence. So we have, for example, 13 community public services around the world. And it's basically everyone can open an account and start connecting the gateways and create their own network, which might come with some limitation, but then it can, to overcome them, can use one of our 6 professional public servers, or even go further using a private server, for example, which can be installed and maintained by LORIOT, so on the cloud, or also even on premise, so within the customer infrastructure. And here, for example, on the bottom, you see also some interesting facts and figures. For example, that we have more than already 20,000 registered users, and also supporting, for example, more than 35 national and regional smart city deployments. And by that, you can already see that it's a technology or solution that it's actually affecting every industry and vertical. So not just smart cities, but also, for example, agriculture or mobility, etc. But I don't want to go so much detail in the use cases as my colleague Ilenia will talk about this later. So already now having a look at the LoRaWAN network architecture. So this you already saw now with Ilenia. Here you can see basically the stack. So we with the devices, the gateways, then we have the network server and the applications. And just to quickly explain you how it's actually working, that you get the data from a device, for example, that is measuring temperature to your application or IoT platform. So it's basically that you have a few devices outside the field, and those devices are broadcasting messages, and with the hope that a gateway is listening to it. And I think it's interesting to highlight that the communication between the gateway and the device is bidirectional. So it means that the gateway can either receive the message, but also can transmit a message to the device. And then once it has been received, the gateway will forward this message to a network server. So in this case, this can be LORIOT, so our network server. And that's basically the network server is basically responsible for managing the gateways, the devices, the application, and users within the entire LoRaWAN network. So it therefore, as already mentioned at the beginning, you can say it's like the brain of the network. And then later, these messages will be pushed to the application server, where it's then basically responsible for decrypting the data that has been received, or also, for example, encrypting the data that will be sent to the device. But now to also better understand really the features of using LoRaWAN, I also want to focus on that you get a better understanding about really what is the difference between LoRaWAN and LoRa. So here you see some of the features, and also at the top a quick introduction. So what is actually LoRaWAN? So what you can see here, LoRaWAN is a wireless, long-range, low-power, wide area networking communication protocol that uses the LoRa physical layer. So here you can already see a bit the difference between LoRaWAN and LoRa, but in the next slide, I think it will become even more clearer to you what are the differences. But to focus on the features. So since we are in this long range, so in the LPWANs, so it has a really long range and deep penetration. So it means that, for example, in regional areas, it can communicate up to 50 kilometers. And for example, like in urban environments where you have obstacles like buildings, etc., this the range is a bit lower, but it still can reach up to 10 kilometers due to this deep penetration. Then another important point is also to focus is the low power. So depending on the device classes, for example, that are used, and also the it communicates, so the data that are sent using really low bit rates, you save battery life. So that means that the battery life can be, for example, reach up to 10 years almost. And this is then also related to low cost. So the maintenance costs compared to other technology might be less. Another important aspect to mention here when we talk about low cost is also that this technology is standardized by the LoRa Alliance, and those standardization is maintained by the LoRa Alliance. For example, also LORIOT is a member of it and is indirectly also contributing to those standardization. And via LoRaWAN is operating in an unlicensed band. So it means that you don't have spectrum fees by using those frequency bands, which is of course then also related to low cost. And now in the next slide, you see really the difference between LoRa and LoRaWAN. So as already mentioned, LoRa is basically the physical layer. So it means it is the chip and the physical signal that is used and modulated for the radio frequency communication. And there you have the frequency bands, so that are also standardized by the LoRa Alliance. And depending on the region, for example, in Europe, you have the 868 megahertz. Depending on the region where you operate, in which band. And then there you have also the LoRa modulation. So this is actually where it's really the transmitting the data over the air and doing this in a long range in a very efficient way. And there on top of that, you have the LoRaWAN, which is basically the MAC layer. So it's actually then the protocol that used in the signal to enable the networking. And yes, and then on top of that, you have your application or your IoT platform. And also to understand a bit better the LoRa technology modulation, and also understand better what is really the difference to other radio technology, is that LoRa is chirp spread spectrum modulation. This was developed by the Semtech Corporation. It was actually developed by a company called Cycleo, but later on it was acquired by Semtech. And since it's using this modulation, it's very robust to interfaces. And for example, you can see here in those images, you can see those chirp spread spectrum modulation. But I think also what becomes also even more clear now when we compare this technology to LoRa to other technologies. In this, I think here you can see it very well, is that you have here the low power wide area networking. There's also within this is LoRaWAN. Then you have the cellular networks and the local area networks. And I think here it becomes really clear the advantage. So you can see that it has a very long range, but of course it comes with the cost of the bandwidth. So it means that it can only very small messages can be transmitted. But at the same time, for example, also it has a great advantage, especially compared to cellular network with the battery power, and because it's using low power consumption. And this is then, as already mentioned before, also related to lower costs. And also when we are talking about, for example, the infrastructure requirements compared to the cellular network, I think it's important to highlight that, for example, a mobile carrier need to provide the infrastructure first, and then you are not really able to create your own fully private network, which is possible in LoRaWAN. And in the next table here, you also can have a better overview. It's actually just summarize what I already mentioned, but give you also a bit more details. For example, here you can really see the network range and also compare the different data rate between the LPWANs, the cellular, and also the local area networking. And from here, what you can see that within those low power wide area networking, there are also other technologies, so not just LoRaWAN. So I think it's also interesting to compare them. So you can see this in this slide. So you have here LoRa, then you have Sigfox and the NBIoT. And in this table, just to quickly really focus on the benefits what LoRaWAN has compared to those two technology, is that, for example, comparing to NB-IoT, is that you don't have spectrum costs, because since you are operating in an unlicensed band, and in NBIoT you have licensed frequency bands, so it means the cost can be really high. Compared to Sigfox, for example, is, I think, to highlight the bidirectional communication, is that it's limited. And for example, as mentioned at the beginning and showing you in the LoRa network architecture, that the communication can be, so the gateway can be either transmitting or receiving data. And this is kind of limited in Sigfox. And I think also with this slide, this will already come to the end, and I hope you got a good overview about the difference between LoRaWAN and LoRa, and also that you have now a better overview comparing it to other technology and seeing the advantage it actually can bring to your use case.
Thank you so much, Manuela. Thank you. Just 1 second. Can you confirm me that you see the slide?
Yes, we can see it.
Perfect. So to put LoRaWAN into practice, we work with a lot of clients in various industries, and they all leverage the features and advantages of the LoRaWAN communication protocol to improve the efficiency, safety, and productivity of their companies. These are some of the areas of application of our MAM module. We have smart cities. In fact, LoRaWAN can be used in various smart city applications, such as parking management, waste management, smart lighting, improving efficiency and reducing cost. Smart agriculture. In fact, the precision agriculture is another very common use case, as the LoRaWAN protocol allow farmers to monitor crops and soil moisture and weather condition remotely, leading to more efficient use of the resource and increases in the yields. Also, we have smart environmental, that in fact LoRaWAN is also perfect to monitor and manage environmental factors such as air quality, water quality, noise pollution, and for example, sensor can be deployed in the city to monitor air quality. We can identify areas where the air pollution is high and so leading to targeted intervention to improve the air quality. Then the smart logistic since LoRaWAN enables long-range communication, allowing the system to send data over distances of several kilometers. It is also ideal to tracking and monitoring assets, such as vehicles, containers, or over long distances. Also smart manufacturing. In fact, LoRaWAN is also used really often in industrial IoT application, such as monitoring the equipment performances, temperature, or humidity. Another interesting use case is the smart healthcare, that is also increasingly using LoRaWAN in a way that is disruptive in the industry. In fact, LoRaWAN in this case is perfect to remote patient monitoring, as it allows the doctors to monitor the patient's vital signals and provide timely care. So we would like also to speak about some success story. These are true real-life application of systems that are using the LoRaWAN protocol and are powered by MAMWLE-xx technology. The first one is an IoT landslide early warning system designed by WiFi and GeoAndes. The second one is a structural health monitoring system used by Modulation, our sister company, and also an industry leader in the smart monitoring of infrastructure. So the GeoAndes landslide early warning system has been designed and installed and tested by GeoAndes in collaboration with WiFi, using the LoRa development kit by Academy Group, which is based on the MAMWLE-xx MAM module. The system is designed to mitigate the risk related to the occurrence of debris flows and snow avalanches along the road in the northern part of Italy, providing a real-time monitoring of the landslide activity and sending alert in case of any danger. It uses a tear-off sensor to detect any breakage caused by a landslide, and the red light in this case turn on to signal the danger. The whole monitoring system includes webcams and operating modes. Can be managed and set up remotely, as the LoRaWAN protocol enables a long-range communication, allowing the system to send data over a distance of several kilometers without requiring repeaters or other network infrastructures. Since the LoRaWAN protocol is designed for a long power consumption, it enables the system to operate on a battery power for extended period of time. The second use case is, like we were saying, from our sister company. The system here combines different types of smart and wireless structural health monitoring sensors based on our MAM by MAMWLE-xx. It provides a comprehensive view of the health of the structure, ensuring safety and increasing their lifetime. It is a reliable and secure remote monitoring system, thanks to the LoRaWAN protocol that is used for the communication between wireless sensors and an online management platform. In fact, the system also comes with an online management platform that offers remote access to the health of the structure 24/7 and also in real life. So it allows a timely intervention in case of any necessary. So since the sensors use the LoRaWAN protocol to communicate, they do not need cables, which means that they can be easily installed and configured, making the whole monitoring process simpler and safer. The LoRaWAN protocol's low power design allow the sensor to function on a battery power for year, which reduce the on-site visits, increasing the work's safety and reducing also the cost of the installations. So here we have two MAM prototyping board in case you would like to test our module. The first one is the MAMWLE-xx by HDM. Is designed to prototype and develop LoRaWAN systems. In a complete development kit consists of a carrier board mounting a LoRa module. The second one is the Cicerone board from MAMWLE-xx that combines our MAM LoRa module and a U-Blox MAX M10 that is a GNSS that is also connected to the cloud locate IoT location service. So it gives to tracking application a meter level accuracy and also a long range and low power data communication. So both the MAMWLE-xx MAMWLE and the U-Blox module are designed to operate on an extreme low power. However, the addiction of saving edge occurs on the cloud locate calculates the delivers the position in the cloud rather than on the device. So questions. I saw that we have some in the box. Just 1 second. Okay. So we are, the first one is good afternoon. Will we receive the recording and the slide after the webinar? Of course, you will find we will be sending the recording to everyone, and also if you need the slide, you can just write to the email that you can see here in the slide, info@MAMWLE-xx.it. Also, we have another question. I saw it. Where is here in the Q&A box? So this might be for Manuela. They are asking Mark Bennett, how does LoRa cope with high density infrastructure such as gas processing plant or refinery?
Yes. No, thank you for the question. I think it's also a very good question. And I think it also maybe becomes also even more clear now with the use cases that also Elenia just covered, to see really where it can be applied. And I think especially now in this with the high density infrastructure, I think why LoRa would be suitable. I think it's especially also with this long range. So it's really communicating in such a long range, and also the deep penetration. So it's even when you have the obstacles that it can still have a range up to at 10 kilometers.
Great. Also, we have another one. Let's see. Okay, perfect. Okay, here they write, does LORIOT offer a free community version for public organization wanting to provide coverage for others to exploit?
So I will also answer this question. Yes, so as you could see also in the presentation, we have, for example, to start with, we have the community servers. So basically anyone can open an account and of course start also connecting the first gateways, and of course to see and exploit, of course, the advantages.
Great. Great. So let's go on. Do you see? Okay, here nothing. Okay, then here Daniel asked, in the presentation from LORIOT, there was a table that showed the differences between low power WAN, cellular and LAN. What do you mean with network range 100, 300 meters for cellular?
Yes, so thank you, Daniel, also for your question. So when we are talking about this with the network range, it's really the communication between those end devices and the gateway. So that's again highlighting, of course, the advantage that LoRa brings, that it can, the communication between the device and the gateway can be, of course, much higher, and this, and of course, compared to the cellular, is decreased. So we are talking really about the communication range there.
Okay, perfect. So so last one is for us. What is the maximum RF power output that can be delivered by the MAMWLE-xx module? This is from Vinette. So thank you so much for the question, Vinette. On our website, that is MAMWLE-xx.it, in the section downloads and datasheet, you can find the datasheet with all the information about the RF power output and so on. So let's see. It seems that the questions are that. And so I will say thank you all for the questions and for joining. And thank you, Manuela, for joining us in this webinar. Thank you so much.
Yeah, thank you for having me here, and thank you for all the participants for joining.
Thank you so much. Bye. Bye-bye.
Bye.